let's just begin. They tell me that this is about art and science, and it just so happens we are right here at the intersection of art and science. And so this show is about, in large part, about my relationship with the James Webb Space Telescope. And these are charcoal and pastel drawings and a bunch of other things like that. So we'll start with sort of the basics, just we'll work into some more difficult things later. So I wasn't a telescope guy, I'm not an astronomer. I live in the city, you can't see stars. I got no interest in any of that stuff. I'm more interested in mechanical things. I've done a lot of work about industrial design and industrial structures, mechanical things. I'm interested in sort of constructivism and precisionism, sort of architecture, all that kind of stuff. Anyway, there was a contest at NASA for artists, and I was one of the people that ended up being able to go out there, to like 10 artists, and I got a tour of this James Webb Space Telescope while it was under construction. And by the time I got out there, I had done a little homework on it and realized that this is amazing. This thing is so cool. It's cool looking, and just all the science behind it and all the mechanical parts and all the amazing creativity that went into building this thing. You know, people think like, oh, there's scientists over here and there are artists over here, but the amount of creativity that was required to do this thing didn't exist in any way whatsoever. They had to invent many things to make this thing possible. So that kind of creativity was inspiring, and it just drove me on further and further. So I did a couple pieces for the show at NASA, I think this one and that one, and then had a little exhibit at the visitor center, and that was great. And then I had all these photographs, and I went out and visited again, and I just kept going on, and I just kept making more and more work, and eventually I had a little exhibit at the National Academy of Sciences, and I kept going, and I ended up with this whole crazy mess of work. So for those of you who don't know anything about the telescope, it's this 21-foot diameter, gold-plated primary mirror telescope that's shot into space. They flung it out over there 1 million miles. So the Hubble telescope's in Earth's orbit, the James Webb telescope's in the sun's orbit with the Earth, 1 million miles over there in the south, about 37 degrees up from the horizon. So if you look really carefully, you could see it. But from day one, when I saw this thing, I knew, like, this is going to change our understanding of the universe. This is a big, big deal, and I'm part of it. Even though my part is like the most insignificant part of this thing, it was still a great honor to be any way connected to this thing. So that inspired me too. So these are from photographs I took, and these are pastel drawings that I drew as photographically as I could. So there's a whole series of these. This in particular, like at one point I went out there, the telescope was pointing up, and it's in the clean room, and they have banks of fluorescent lights on the ceiling, and each bank of fluorescent light shone down on the gold-plated mirror, but because the parabola refocused itself back up on the ceiling, and so these are the reflections of the telescope from each of the fluorescent banks back on the ceiling. So a lot of these pictures are sort of derivatives of the thing itself. Now, the point of this telescope is not to image the ceiling or this iron railing or this ugly fluorescent light. It's to image the infinite. But I liked it because it has this sort of interesting juxtaposition of what I call like the extreme exquisiteness juxtaposed with the mundane. And so there's that dichotomy, and that has something to do with the title of the show, which we can get into a little bit later, about the ghost in the machine and the sort of duality of a lot of these things that I've been working on. So we're gonna walk now. If you want chairs, grab one, and we'll just keep going this way. So these are sort of similar. These are, again, from photographs I took when I was up close to it. and I cropped them very tight, which sort of amplified the abstract nature of the thing. This is the instrument bus covered in a aluminized mylar, we'll call it. It's Kapton material. And I did a few things, like, I did this circle and I inverted the image on the outside, so this is a negative and that's a positive. So there's a couple graphic things, but they're more or less photographic versions of just a part of the telescope. And I was just found all these interesting sculptural aspects of it, and that's why I started drawing it. Now, the question is, why draw this thing? I took the photograph. What's wrong with the photograph? And that's a good question, because it's a lot easier just taking the photograph. But in my past artistic endeavors, example over there, I used to just do straight photography and then make them some large versions, but it wasn't really enough for me, so I would manipulate the photographs. That one I did a mirror image, and then I was doing images of factories and stuff, so I would actually put iron powder onto the surface of the photograph and rust it, so bringing sort of a sculptural patina aspect into the work. And then I don't know, I did that, and maybe that wasn't quite enough. So then I started drawing my work, because it just sort of was one step removed from photography, and it's, it takes me a couple months to draw this, and it's, that amount of intent and time and dedication to one thing sort of puts it at a different level, and it sort of frees you up from this nagging thought I had that, is photography enough, And so once you do this, it's like, oh, he's an artist, it's like you can do whatever you want, right? No one can debate that. So, and then the charcoal part, if I had any sense, I would use a pencil, because you can control the pencil very easily, but you don't get the tones. My background is like black and white photographer, and so when you work with charcoal, if you make a big black spot on your paper and then you smear it, you know what you're going to get. You're going to get a gradient tone from black to medium gray to light gray just automatically, and those are photographic tones, like Ansel Adams or Edward Weston, or, that zone system of photography, which I love. So charcoal is closer to photography than anything. The problem is, how do you control it? So you can take pieces of paper and sort of mask it and get a straight line. But when you're doing the odd shapes, really the easiest thing to do is have a piece of paper and cut it out. So what I would do is I would take the photograph, print it full size on crappy paper, and then I'd cut out the shape. So if I wanted this shape, because I'm using charcoal, it's a big mess, The pencil you could do that, but charcoal you can't. So I cut this shape out of the paper and then smudge it, and then put the paper back together with some tape, and then I go on to the next shape and cut that out and do my smudging, and then go on to the next thing. And then when you're all said and done, by accident, you end up with this. This is not the intent. This is just a tool. This is the mask. This is the backside of the mask. So that shape I pointed out, that's this shape here. This is flipped over. The photographic image is on the other side. So this is the tape holding all the pieces together with my dirty fingerprints all over it. So this is just sort of a derivative, again, like one more step removed from this telescope. So I started with a telescope and all the amazing engineering and what they're going to find, and they end up with dirty tape. So that sort of brings me to the title of the show is called The Ghost in the Machine. So that was the intent here was, I've got all this work here. I don't know if you've seen them, but it looks kind of different. Like what does this have to do with that? What does it have to do with that? Just visually, they're kind of disparate. And so these are some older pieces. So I thought long and hard about this. Can I show all these things together? And what is the commonality? What's the common theme that holds all this work together? And I hadn't really thought about it, because a lot of it's just intuitive. You take this picture, you don't know why, because you liked it. Well, why did you like it? Well, because of a whole lifetime of looking at stuff like that and thinking about it. So, a lot of this is just intuitive, but when you're faced with the director of the museum, and he's like, I need something when writing. he's just breathing down my neck. And so I had thought about it long and hard, and I came up with this idea about the ghost in the machine. What is the commonality? So it's that everything here has this sort of immaterial presence to it. And the philosophical concept of ghost in the machine, it was a concept of called dualism, or mind-body dualism, or mind-thought dualism. So that the philosopher Descartes, Rene Descartes, he thought like there's the mind and there's the body, and they're separate. And he had a whole thing about that. And then another guy came along in the 40s. His name is Gilbert Riles, and he said, "No, you're full of shit. They're the same. The mind and the body are together." And he made fun of Descartes by saying, "What you're talking about is like a ghost in a machine." So my work is kind of somewhere in the middle of that. It's there's the material and the immaterial, and I've sort of combined the two. So this is sort of immaterial. This is, the residue of me in the process of that, which is an abstraction of that, and so like these older ones, okay, it's a machine, it's very physical, but then you got this peeling paint, and the peeling paint is like an element of time because time has passed, and there's like an element of nostalgia, and those are all intangibles, So that's the dualism of the tangible and the intangible, the presence and the immaterial, the ephemeral and the solid. And then also, as we go around here, sort of, I bring in like space and time, which are, there's a dualism. There's space. It's like you go through space and then you go through time. But then there's also space-time, and that's what Einstein sort of brought together. Like it's a unified thing. And so I sort of try to explain that a little bit. So that's that. We've done that. We'll go here. So then they launched the telescope in 2022, 3? One. And that was that. You're never going to see it again. And you talk to people at NASA, and it's like, hey, can we see it? And they're like, no, can't see it. Too far away, too small, too dim, not interesting. We're not interested in looking at it. We're only interested in looking at the downlink for the data that it images. So I wasn't alone in this thinking. I came across some amateur astronomer, he was in Italy, who he had access to a sort of university level telescope, and he wanted to see it. And it's like, well, that's just exactly what I wanted to see it too. So he found it. You can put in JPL's positioning data, and he found it and took a time-lapse photo of it going across the sky. And I just found that amazing. And that's like, oh, I want to do that. That's exactly what I felt too. And I'm not alone in that. There are other people in the scientific world who also wanted to see it because they spent years on this machine, and they were, I was 30 feet from it, and they were even closer, and they had this connection. And it's there, but it'd be fun to see it. So I thought, well, maybe I should do that and borrow someone's telescope and learn how to use it, and go somewhere far away that's dark and figure out how to image it. And it's difficult. I don't know. So I thought, well, I don't need to do that. He's already done that. I can just use the positional data and draw it. I'm drawing it anyway. That's what I'm doing. So why bother imaging it? So you go to JPL, you put in your location on the Earth, you put in the time of the year, and there it is, and then I can simulate this photograph. And I did that. So that's what this drawing is. So this is, aesthetically, it's a very boring drawing. It's just a black thing with some white dots. But in it is this tiny line. And that's the telescope. So that's the far away shot of that. That's the close-up. This is the far away. And so this is, I did it the time when I conceived this drawing. I used actually my birthday. So on my birthday, it was going across Leo. So this is an accurate drawing of the stars. So here's Regulus, and then these are the stars of Leo. This is, so they're all in there. You can read it if you know what you're looking at. And it was important to me to make it accurate. And it's just, so what I really liked about it was like this emotional feeling I had, like, even though it was simulated, it was, It's like the telescope is sending a few photons back to me like a postcard, like a little letter home. And I have that connection, this enduring connection. And I know it's over there in the south, but that's what it looks like. And so I just sort of kept going with that idea of this imaginary camera I had based on data. So there's another one. This is like a 4-hour long imaginary time-lapse photograph. And this is the Milky Way, and here's Sagittarius, and here is Coronis Australis, and you know, they're all in there. You can read it. And here's the telescope going across the sky. And this is as if you had a tracking equipment on your camera, and so that it tracked the stars so they're not smeared. So they're all in here. Here's Sagittarius, and this is Vega and Altair, and here's the telescope. So we'll go down here.
Tim, I have a question.
Yes.
Sorry, this is Joel. How do you draw stars? How do you draw it? I mean, because it looks like a photograph of space, but obviously you spend a lot of time getting it exactly right scientifically, you know, the stars in the right place.
Yeah.
And then do you just like go around and individually draw? How do you make all the stars? How do you get them exactly the right size and brightness or magnitude?
I don't know, just poke at it. So there are websites that, you know, you can put in the position and see all the things accurately, which I used, and then I take stills of that and I project them. So I project the stars onto the drawing,
Okay.
and then I know their magnitude and their position and all that. So it's not just like, I'm not some genius who knows where all the stars are, you know. I'm a cheater. I can use every tool I have at my disposal, and that's one of them. These are projected from actual, you know, simulated websites that simulate where all this stuff is, because everybody knows, including Heidi, where all this stuff is. I didn't. I had to learn a little bit about it.
Black space, is that charcoal?
This is Sumi ink and acrylic paint pen, and then a little bit of pastel around the halo. And then if people who are very keen know that this is probably taken from the Hubble because it has 4 diffraction spikes. And I didn't have to tell them, they knew already. Because if it was a JWST image, it would have 6 diffraction spikes. All right, we'll go down here. So I continued on this idea of using positional data and with my imaginary camera. And I got this idea from another guy, another astronomer on the internet. And if you take a photograph every night pointing south at the telescope for a year and stitched them all together and plotted the points, you would get this. So the telescope does 2 orbits a year around this mythical spot in space called the Lagrangian point 2. I won't get into it because it's complicated, but even though it's going in a circular path, but because the Earth is tilted at 23.5 degrees, the Earth doesn't wobble, but it's like it wobbles over the course of a year. And so this circle is kind of going like this. So it's like, you know, instead of going like this, it's going, and you end up with this crazy pretzel shape. So it's very abstract, but this is all data-based, you know. And so this is over the course of a year, and then the stars behind it go in a sinusoidal pattern, and a sine wave, because anything that goes in a circle that moves, you end up with a sine wave. And this is actually the course of a year and a week because of this overlap, and it processes. So it keeps moving slightly over, and so that, and then I thought, well, I'm going to do one with, well, this is before I knew anything about stars. I knew the Big Dipper, and I knew Orion's belt, and that was my extent of all my astronomical understanding. So I thought, well, I'll just draw stars. The stars are random, so I'll do a fat line and a skinny line, and another line that's far away and one that's close by, and sort of make it random. And then when I was all done, you look at it, and it's like, well, it couldn't be more orderly. That's no good. So I thought, well, I need to understand this better. So I learned a little bit more about stars, and I decided I wanted to have them start and stop. So this is 3/4 of a year. So like the stars start here, and then they come back around and stop there. And each one of these dots is like 10 days. And then the thing starts and stops. So that was a little better. I need to know more about that. So I learned more about the stars. And so this is even more accurate. There's a different 3/4 of the year. And so you can read this one a little better. So here's Orion's belt. Here's Betelgeuse. This is Sirius. You got Aldebaran. You've got learned about the winter hexagon. And you've got Aldebaran. You've got Capella and Pollux and Castor and Procyon. So they're all in here, and you can read it if you want. But it's all based on the JPL's positional data. So then I look at this one here. I was looking at astrophotography online, and I like these polar images. The stars go in a circle. If you take a time lapse, like an 8-hour time lapse of the North Star, and that's cool. I thought, well, I'll draw that, and I'll just put the telescope in there. But the polar star is in the north, and the telescope's in the south. So that's no good. So I thought, well, what I'll do is I'll just get on my imaginary plane. So I get on my Gulf Stream, and I went to Antarctica, and because I go to the south, where the telescope is. And of course, when you get to the south, the telescope's in the north, because it's in between. So that was stupid. That was a total waste of an imaginary trip. So I got back, and my plane came home. And then I thought about some more. Like, how do you see something that's in front of you and behind you at the same time? And it took a while to figure that out. And it's like, oh, it's a mirror. So I put my imaginary mirror up, and so this is reflecting behind me. So this is Orion, and this is Sirius, and then here's the telescope traversing the sky in the mirror. And then this is the opposite. So I looked south, and then you can see the telescopes in here, this dotted line, and here's Orion, and here's the Gemini twins, and then this is behind you, the polar stars, and there's the Little Dipper, and it's all in there. And I thought, well, I got this imaginary plane. I better make the most of it. So I flew to Ecuador. I thought, well, let's go to the equator. So I went to Ecuador, and I got on top of a tall mountain, and I got a imaginary wide-angle lens, like a 180-degree lens, went up to the tallest mountain I could find. And if you take that picture, what do you see? Well, the stars go directly overhead in a line. Well, that's kind of cool. And then if you have a wide enough angle, you've got the North Star here and the southern stars here. And here's the Milky Way, and here's Sagittarius, and here's Vega, and so they're all in there. And then the telescope is going in a straight line right across the sky. All right, that's enough of that. We'll go over here. So before I did all that, I came across some interesting studies that were related to the JWST because they wanted to use, this is before they launched it, they wanted to use it to help image the black hole that they thought was at the center of our galaxy. So previous to using it, they had been using this, there was two groups, the UCLA Galactic Center group in LA, and then the European Space Agency, they also were interested in this problem. The UCLA group was using the Keck Observatory in Hawaii, and the ESA was using the VLT in the Atacama Desert in Chile. And it's a very difficult thing. They had a rough idea where this black hole may or may not be, but it's so difficult. It's like looking down the beach, quarter mile, and trying to find 20 grains of sand that are moving in a slightly circular pattern. And it's like foggy out. And so it's very difficult to image this thing. And nevertheless, they're clever people, and they did. And they found a spot where these stars were going around something. Now, the black hole, you can't see it, because it's a black hole. But they were going around something, And so they analyzed it for like 10 years. And so like this orbital path here of this star is like, I don't know, 50 years long, something like that. So, you know, they only could see it from here to here, but they're clever people, and you can interpolate the rest of it, and you can know the rest of that shape of that elliptical orbit. And if you know the frequency that it goes around and the shape of that orbit, then you know the mass of the thing that's at the center that balances this equation, you know, that keeps it in a stable orbit. If it's unstable, it'll either fly off or crash in. And so when you do that with all these stars, you end up with the answer that there's something here that's 4 million times the mass of our sun. And this area is 26,000 light years away. And it's difficult to image because it's like through the plane of the disk of the galaxy, and there's a lot of dust and garbage and candy wrappers and stuff out there. And so that's why they wanted to use the JWST, because it's infrared and you can see through dust better. So I started doing these sort of orbital mechanics things. And this is another version, and this is 3 stars going around the black hole. So these are sort of, again, derivative. It's not exactly JWST, but it sort of got me thinking about these orbital mechanics. And we'll go over here. So this is a difficult wall to hang anything on because of the radius of the curve. So just putting these 4-foot wide pictures on here doesn't really work because they stick off the wall, and I didn't know what to do with this. And finally I came up with this idea. So I wanted to do a long drawing that was just 2 parts. There's A and B, left and right, solid and an immaterial. You know, like this is the body and that's the mind. So this sort of has to do with the dualism of the whole show. So I made this custom for this wall. So this is the inside of the camera, one of the cameras on board, the mid-infrared imager. And this is the light path going through it. And I started getting interested in that because it has this ghostly feel, and I started thinking more about that, and like this immaterial thing combined with this material thing. And then the other reason I did this is because you can't see the picture in one viewing. The only way you can see this is to travel. And when you're traveling in a circle, well, in an elliptical orbit, like all these things. So you were part of the picture, and also there's an element of time. It takes you some time to go from left to right or right to left. And so, you know, you have space and you have time, and then there's space-time, and that's another element of this. So, you know, you got all the stars, and I drew them accurately, and then you have this sort of gaseous cloud that connects the 2 ends. And so, you know, Newton was talking about, you know, he invented gravity, you know. Before him, everyone was just floating around. And then he said, no, you got to stay on the ground, and this is the formula for gravity. And then Einstein came along and said, yeah, but that's no good. Gravity is actually just a function of space-time, and that space is curved. So light goes in a straight line through space, but space is curved. So light curves also. So this drawing, everything is curved. The frame is curved, the wall is curved, you know, because space is curved. And you're part of that. And to see this thing, you've got to, you know, travel around left to right here, or right to left. And so in this end is one of these black hole drawings. And anytime you're talking about a black hole, you're talking about like a singularity, like it's infinitely dense. And anytime you're talking about infinity, you're talking about something that's unknowable. It's intangible. So this is the sort of the mind part, and that's the body part.
Pretty orderly mind, Jay.
It's a mess in there. You don't want to go in there. It's bad news.
What is the white? What are you getting at with this white?
What am I getting at?
Yeah.
The original concept is just connect the two. Connect a white line between the two.
Right.
It was just simple. Like A and B, connect the two. And then I ended up doing it in a way that ended up being sort of gaseous and nebulous. And so I came up with this idea of, the way I did it actually was I used cornstarch, and I sprinkled it on there, and then I sprayed black paint over it. So I used it as a mask, and then I brushed it off. Don't let the guards see me. And revealed the white underneath. and it had this intended sort of gaseous effect. So then behind you here, eventually my wife gave me a telescope. So, I learned how to use it a little bit. And as an artist, you always do things backwards in the wrong way. And, that's part of the fun of being an artist. So you're supposed to focus the telescope, right? First page of the thing, focus the telescope, you jerk. And so I did the opposite, and I defocused it. You make it as blurry as possible. And like if you image the star Betelgeuse, it's kind of a little bit orange, but it's very small, and it's like it's a dot, it's a white circle. But if you defocus it, you can see the colors much better, and I thought that was cool. So, and then the size of the circle is relative to the magnitude of the brightness of the star. So this is Orion, and there's Betelgeuse, and there's Bellatrix, and Scythe, and Rigel, and Alnitak, and Almond. They're all there. And then here's the telescope traversing Orion when I conceived this drawing. Let's back up a bit. So this is another one of these things people always ask me about. I always sort of skip over this one. This is back when the telescope was still on Earth, and after they finished building it, they took it down to Johnson's Space Center, where they have the biggest cryogenic pressure testing chamber, where they tested all the Apollo lunar landers and command modules. And they put it in there, and they could unfold it because the mirror folds. It's big enough that they could have the whole thing open, and they could see if it functioned at this temperature, minus 40 degrees Kelvin, which is like minus 250 degrees centigrade, and negative, very low pressure. They were trying to, ostensibly, they were trying to break it. They're trying to break it here, so they don't break it there, because there's no fixing it once it goes out there. So they were trying to simulate all things and see, does it break? Does it work? Do the photons go into the bucket? Do they come out of the bucket and go down the hose into the other thing, And so they did that, and that's what this was. This is the official photographer for NASA took this photograph from which I did the drawing. And I was working in Photoshop to, edit the picture, and then I put a little filter to sort of intensify the lights and made this sort of alien feel to it. But the photographic elements in here, like this is test equipment on the ceiling that's reflected in the mirror of the primary mirror. And then these things, I came across the European Space Agency, who was primarily responsible for the mid-infrared imager camera, which is an amazing technical feat. It's a camera about this big, and it's incredibly complicated, and I understand about 5% of it. But they made a 3D model that you did a little video fly through, and I liked that a lot, and it had sort of very sculptural qualities to it. So I started making drawings of this little video that they had put together. And so this is the inside of the camera, and this is the light path going through the camera, bouncing around. This is a different part of it, which is going through some gradient. Gradient.
Spreading the light out into colors.
Spreading it out into the different wavelengths.
Yes.
But then it recombines it later. So there are individual sensors in here somewhere, or we're going to have to get the expert on that. All right, let's go this way. So I post stuff on Facebook and Instagram once in a while, and there's some guy started liking my work. Turns out he was worked on the JWST, and he was some optical engineer. His name is Scott Acton, and he reached out to me, direct message me saying, I got something I want to send you. Sure. So he ended up sending me a little scrap of Kapton film, this same stuff that the instrument bus is made out of, that was left over. They fitting this stuff around it, and they have scraps, and he kept several pieces for himself, and he gave a few away, and he gave one to me. But he had the same impulse that I did, that he wanted this souvenir. He had spent a lot of part of his life on this machine and felt this deep connection, and I thought I would enjoy it, and indeed I did. So I took this little scrap and I photographed it in 4 different ways. So it's the same piece, and just folded it and made these sort of abstract sculptures that I photographed. But I like it just because it's, it's sort of this personal memento, and knowing that the other part of this thing, the thing that this was cut from, is over there, 1 million miles away. And the other part is here. So I have this enduring connection, which I found, sort of emotional. And then we'll go here. So this is again the mid-infrared imager camera. There's another camera, the near-infrared. This is the mid-infrared. And then there's a fine guiding steering mirror and camera. So again, it's super complicated, but it makes this amazing sort of sculpture. So the beam comes in on the other side of this machine, which is actually that thing out there, and then it splits up into 4 different wavelengths, and then it comes up, and it goes, hits this mirror, comes out, hits that mirror, hits this one, hits this one, hits this one, and then finally gets to some kind of imager where they can, see in this wavelength and that wavelength, and then you can do different science on the different wavelengths and understand different things. You can recombine it and make a pretty picture. So it gives them a lot of flexibility. There's also a filter wheel on the other side where they can filter it this way and that way, filter for different wavelengths. They can put coronagraphs on there where they can block the star so they can see the planets going around. They can put gradient filters and polarizers and all kinds of things. And it bounces around many times for unknown reasons, which will be illuminated now. Why does it bounce around so much? People always ask me, and I can't answer it.
It bounces around for different reasons. Sometimes we're trying, as you mentioned, we're splitting the light up into different colors, right? But then they wanted to have this thing very compact because we're going to launch it on a rocket ship. And so if you didn't fold the light this way, this instrument would be much, much larger. And so by folding it in this way, you can have it small, compact, weighs less. All those are good things for things on rockets.
That is a good thing. Very lucky. And I use these colors. I'm not a color guy. I think in black and white. I don't know why there's so much color in this show. But anyway, this is like CMYG. It's like, cyan, magenta, yellow, and green. They're just sort of primary inverse colors, and they're like technical colors, and so I can get behind that. I'm not a color guy, but I like technical things, and so these are technical colors. But this is all simulated because this is infrared. You can't see it. We don't see in the infrared, so this is not what it looks like. This is just someone's idea of what it, just so you could understand it. So I made a video that was sort of work in progress, and you can go. There are QR codes under all these descriptions, takes you to a better description of these things, and there's also other stuff there. There's some audio of talking about it, but there's also video of how I made these things. So before you ask me how I made all this stuff, go there and see what happens. But one of the video I made about this, I got a little jiggy in the video editing program and put some groovy filters on, and one of the filters sort of just smears the work. And I like that enough that I just took one of the frame grabs of that, which was this. And so this is this thing just smeared. So it's actually turned 90 degrees, but this wheel in the middle is this thing just pulled apart. And again, it's just a derivative. It's just one more step removed, but the inspiration is still there. This machine that does all these amazing things, and it's inspirational enough that it gave me enough energy to spend 2 months doing that. And then the thing out in the hall, the big one, that's again this camera. This is the other side. It hits this side first. So the mirror, the primary mirror, collects all the light, bounces it to the secondary mirror, comes down to the tertiary mirror, goes this way, goes that way, comes to this thing here, and then the beam comes in, and then they start splitting it up into the 4 different wavelengths. So like that thing there is a pick-off mirror, and it takes off, well, they call it the cyan, and then it goes a little further and it picks off the magenta, and it goes a little further and picks off the green, and then you end up with the yellow is left over. And then it goes, and then somehow it goes through this thing and comes up on the other side into that part of it. So it's like a two-sided thing. But again, it's this amazing sculpture with this made out of photons, and that's sort of the immaterial and the material and this duality that it sort of encompasses a lot of this work. That's just a smaller version of that thing over there, turned at 90 degrees. This was built, I did design this for this wall, and I designed that thing for that wall, and after this show's over, I don't know what's going to happen. It's going to go back to my studio and collect dust, I guess, unless anyone needs this for their powder room, which I'm willing to talk. We can negotiate something.
It's also the size of your studio plays a part.
The studio is a little bit of a problem. So my studio has got a towering, soaring 7-foot ceiling with beautiful, not northern light. It's in the basement, and so I could only see like 2 of these pieces together at a time. So I never saw this thing until I installed it. The same thing with the big curved one. My wall is only like 22 feet long. So I had to work in pieces, and I never saw the whole thing until I installed it. And
I have a question regarding the black hole. Has it been made especially for this exhibition?
the curved one?
Yeah.
Yeah.
Yeah, of course.
Yeah.
Yeah, because you don't have.
Out of a curved wall. I don't have a wall even that long. I never even saw it before. So this was that was news to me. And luckily it worked out okay. So I made some good guesses, I guess. Any questions? You must have something. Come on.
An observation, actually. When you started your talk, you talked about the beauty of the telescope itself. Just fascinated with that. And then when we look at your charcoal drawings up, down, over in the other room, it's obvious that you can recognize beauty, and then you capture it in your work. And then as we move through your show, I hear and I experience that what you're capturing is an experience rather than just something you saw.
Right.
And that's evident in your work, and it's alive that way.
Right.
I'm really moved by that.
Thank you.
You're working with the experience, and you're having your own experience as the artist at the same time, and it's just showing up.
Well, that was hopefully the intent that came across, this sort of immaterial presence of all these things. You know, like, why did I choose that round disc? You know, there was other parts. How do you frame things? You know, what in your past drives you to, you know, compose it that way and frame it that way, and sort of accumulation of a lifetime of looking at things, and you end up, you know, with these odd sort of abstract things. But I'm not an abstract painter. I don't know what you call me, a realist. I don't know what you call it, but you know, I'm interested in.
You don't have to call it.
I'm interested in reality.
Yeah.
You know, and or my reality, and the presence of all those decisions that are sort of embedded into these works.
Yes. Thank you. Yeah.
You might have had this question asked before. Were you a photographer first and went into drawing, or the other way around?
I was probably a photographer, and then when I went to art school, I didn't like my photography teachers. I thought they were terrible. So I said, well, this is a waste of time. So I became a sculptor, and I actually studied sculpture. And I did that mostly for quite a while. And then when you can't get rid of your sculptures and they clog up your house and your studio, you can't be a sculptor anymore. So then I started doing wall sculptures, because I got, so my sculptures got sort of thinner and narrower, and then when your walls fill up, then, you know, you start getting into it's like, why use the photos as a source material? I'll just use the photos, and then I started just doing the photos. And then I got to the drawing. So it was sort of a spatial progression from, you know, 3 dimensions to 2 dimensions. You know, so there's a lot of practical elements to all of this.
To your sides, kind of joined the photography and the, you know, working with your hands.
And before I got into this sort of digital photography, I was doing sculptures, like wall sculptures, and I would put liquid photo emulsion on them, and I would develop them like the piece of concrete. In the darkroom, in the chemicals, and so I have photographs on the concrete sculptures, And that was a huge hassle. And I did a few of those, and it was like, this is terrible. It looked cool. I love the result. And then I discovered like digital photography, and this is a long time ago, and it's like, excellent. I'm never doing that again. So that was my sort of combining photography and sculptures directly.
So how does this work for you?
When I draw these things, like, I spend a lot of time trying to get the details right, and sometimes I think, who's going to know the difference? That thing's hard to draw. I'm not going to bother with that thing. But then I always think of like, who am I drawing this for? Is it just art people, or is it scientists too? And it's like, so I spend the extra time. I do it because in my mind I think that someday the person who put that nut onto that thing, it will come like, that's exactly it, and I'm like, yeah, and that would bring me a lot of satisfaction knowing that I did their work justice. And so that's one of the reasons I go to this length. But during the opening, a guy came up to me and was like, hey, I was just down the hall. My daughter is having a choral recital. He's not an art guy. He just happened to just killing some time. He just wandered down the hall here and came into this, and he's just like, I worked on this telescope. How did this come to be? He was just floored, like, this is my work here. He had no idea about it. So he was thrilled. And then the woman who is the head of this camera in Europe, the European Space Agency's primary scientist on this camera, she has contacted me recently, and she it's happened last week, she wanted to use some of these images to illustrate her talk to the European Astronomical Society. And so that was a huge honor, and that's all I want. All right. Last chance. You're never going to get another answer. Thanks for coming.